Hello and welcome back to Introduction to Astronomy. In our previous segment, we were talking about how gravity causes the tides and how the gravity of a planet causes tides on a moon, and how if those tides are strong enough, it could actually pull that moon apart. Well, in this segment, we're going to again talk about the tides and how gravity acting on those tides can actually change the spin rate of a planet. It can change also the distance that the moon is from that planet. So if you look at the picture there, you'll see that here is a planet, and then let me very much exaggerate the tides, but those tides are being caused by a moon over here. So the gravity of this moon is pulling on the water and it's causing these tides. Now that's what would happen if the Earth was not rotating, so that the tides would always be pointing towards the moon. But because the Earth is rotating, so the Earth is rotating counterclockwise like that, and so what's going to happen is that instead of looking like that, the tides are going to look more like this. So you see that the tides have shifted around because of the rotation of the Earth. Well, the moon over here doesn't like that, so the moon is pulling on these tides, trying to pull it back the opposite way. And so the net effect is that the planet is going to slow down in its rotation rate. Okay, but you can't get something for nothing. So if something here is getting smaller, then something over here has to get larger, and it turns out to be the distance. So in order to compensate, then the moon is going to move further away so that the r gets bigger as the rotational speed gets smaller. And if you look at that chart that I've given you there, it shows that when the moon first formed, the moon was very close to the Earth. So it was approximately located at a distance of 1/3 of what its current distance is. So that would mean that the moon would have looked 3 times bigger in the night sky. And you also notice that the moon would have orbited the Earth once every 6 days. And the moon would have spun once every 20 hours, and the Earth would have also spun once every 20 hours. Okay, so I got these facts off the internet. So they've done calculations based on when they think that the moon formed, how close it would have had to have formed, and so that's where I'm getting these numbers from. Now today, the moon is further away. It's been moving at a rate of approximately 2 centimeters per year. So every year, the moon gets about 2 centimeters further away from the Earth. And now you're saying, well, 2 centimeters, that's not much. Well, if you multiply that by millions of years since the moon first formed, that's a long distance. So that today, the moon has an orbital period of 31 days, and it also spins once every 31 days, and then that's the reason why you only see one face of the moon, the man on the moon, the face of the man on the moon. Okay, you only see one side of the moon because it's rotating at the same rate that it's orbiting around the Earth. And then the Earth's spin period is once every 24 hours. Now in the future, so they have calculated that 15 billion years into the future, that's when the moon will finally stabilize in its orbit and will stop moving further out. And so when that happens, the moon will have a orbital period around the Earth of 45 days. The moon will spin once every 45 days, and then the Earth will spin once every 45 days. So that means that one side of the moon will always be facing one side of the Earth, and then they both will be in orbit around each other. So kind of cool stuff. And it's all as a result of gravity. Okay, in our next segment, we are going to talk about the reason why the planets go around the sun, and it is not because they've eaten their Jimmy Dean sausages. I'll see you in just a moment.